Thanks everyone for coming. It's such a pleasure to be here tonight and to share this space with Natalie, whose work I'm a big fan of and I admire a lot. So as Deborah said, I'm a science journalist, and so what I do is I talk to scientists. There are a couple seats up in front. If there's one here, one over there, people want to sit. I take the stuff that scientists trade in, which is data, and try to translate that into a format that is palatable to the general public. And so I thought I would start by just playing for you the first 3 minutes of a radio story that hasn't yet aired, but will soon. It comes from a reporting trip that I took earlier this year to Greenland. And I'll just set it up by reading for you the way the host would introduce the story. Reporter Ari Daniel traveled to Greenland to stand on the front lines of our changing planet, but he didn't expect that he'd be walking into a mystery, a whodunit, or rather a whatdunit, of epic proportions with consequences that impact us all. The breakfast is ordinary. Granola, yogurt, bread, and jam. Everything else is anything but.
You pay $1 million for a view like this. Pretty nice breakfast buffet, I guess, for sitting out here next to the ice sheet.
Gordon Hamilton, detective number 1 in our story, is sitting on the rocky rim of a glacier. Kind of figures. I mean, the man is a glaciologist from the University of Maine by way of Scotland. But this isn't just any glacier. It's the Helheim Glacier, one of Greenland's biggest, a 3-mile-wide river of ice that flows into Sermelik Fjord on the island's southeast coast. We're on one side of that fjord. Across, on the other side, that's where it is, what drew us here, a horizontal stripe running the length of the fjord, about 600 feet above the ice.
I mean, everybody who's come here with me said, what's that line over there? And I said, well, that's where the glacier was in 2003. It's kind of like the signal clue that something really big had happened.
Hamilton calls this clue the bathtub ring.
It represents the former height of the glacier surface.
Helheim's surface sat right around that line for decades, maybe longer. But about a decade ago, in the span of just a couple of years, it dropped dramatically.
And what that means is that all that volume of ice from the current surface up to the height of that bathtub ring, it's now in the ocean.
And the question is why?
Why? Why did that happen? Right.
And what it might mean for all of us. You see, it's not just Helheim. Most of Greenland is covered by a massive block of ice. Helheim is just one of thousands of glaciers that drain that ice sheet into the sea. And right around the time this bathtub ring showed up, some of the other big glaciers also changed suddenly.
They retreated very quickly back up their fjords. Their flow speed doubled or tripled. And this had the effect of putting more icebergs into the ocean. And when you put icebergs into the ocean, you cause sea levels to rise.
So what happened here? To find our next clue requires going airborne.
Is it clear on your side? Yeah, it's clear.
One perk of being a glaciologist is the helicopter rides. This one's taking us a few miles down the fjord beyond the glacier's terminus. The pilots got the thing hovering like 50 feet above the water below. There are icebergs the size of football stadiums in every direction.
So, open the doors.
Daniel Sulak, a graduate student from the University of Oregon, slides the chopper door to one side. It's okay, he's roped in. He sits on the floor with a spool of copper wire that's got a thermometer on one end.
Okay, prepare for launch probe.
Sulak shoots the probe into the water.
Did you see this, Ari? The data's plotting on the screen as it drops through the ocean.
I lean over Hamilton's shoulder and watch the temperature plot in real time on a screen. It's a hair colder than 0 degrees Celsius near the surface, 32 degrees Fahrenheit. But it's not frozen because salt water freezes at about -2 Celsius. As the probe goes deeper, the water gets even colder, but then it gets warmer again. And at the bottom of the fjord,
Temperature is 4.04 degrees centigrade.
That's 39 degrees Fahrenheit, warm enough to melt glacial ice.
We think it's this water that's coming into contact with the edge of the ice sheet and causing the rapid melting of the outlet glaciers.
For Hamilton, it's a key clue. Hamilton thinks warming water below was probably what triggered Helheim's dramatic change. Of course, that answer leads us smack into another question. Where's all this warm water coming from? Okay, so there are basically 2 parts to the beginning of that story. There's the part where I explain that the glacier has dropped in height, and then there's the part where I talk about the warm water coming into the fjord to melt it. And let's look at that in terms of how scientists might talk about it. So this is a 2007 paper that Gordon Hamilton published, and it says, the title is Rapid Volume Loss from 2 East Greenland Outlet Glaciers, including Helheim, and these glaciers are losing ice at a rate of 51 plus or minus 8 cubic kilometers per year over that time range. Here's a plot from that paper. So all of the pink and red, so we're looking overhead, is the ice. And you can see that the redder it is, the more ice, the greater the vertical drop of the ice. For the second part of that, that story that I just played, this is an article that publication from 2011, Impact of Fjord Dynamics and Glacial Runoff on the Circulation near Helheim Glacier. And here's a plot from that one. And so this is depth on the y-axis in meters and temperature on the x-axis. And you can see, so we're looking at the red lines because those are data that were collected in the summer. And so at the surface, it's at a certain temperature, like around a little bit warmer than 0. And then it gets colder, and then it gets warmer again when you get to the bottom. So this is how scientists might talk about the data. This is how I do not like to talk about the data. I trained as a scientist, as an oceanographer in graduate school before becoming a journalist. So I know this is how scientists communicate easily and efficiently. But this is the sort of thing that when given to the public is not the most tasty. So I try to come up with tastier ways of doing it. And when I think about telling a story, I think about it's like leading someone down a path. And what you want to do is you want to welcome them along, and you hopefully will encourage them to start with you at the beginning and come with you all the way to the end. And it's at the end that there's the payoff of having heard the whole thing and seeing the whole package. And so sometimes I think about it, it's like threading beads onto a necklace. And each bead is kind of an idea that I want to communicate. And when strung together, it gives you the kind of full narrative. Now, each bead, I think of like a kind of empty space. And in my ideal stories, I'm able to kind of give each idea a home. And so I think, well, how might I inhabit this space? How can I let this idea bloom best? And so I'll populate that stage with a set, with characters, with dialogue, with some tension, and in so doing, kind of create a place for that idea to live. And so in this particular story, I had this idea that the glacier height dropped, and this idea, which is that the reason that it dropped was the warmer water coming into the fjord. And I thought, what am I going to put up on these two stages in order to present these ideas? So for the first one, I thought, well, we'll start at the glacier. And actually, I don't know if you can see, but that's the bathtub ring on the other side. That's the light bit, and then that's the dark bit. And that's 3 miles away, and you can see it all the way across. And I decided to start the radio piece where we start most of our days, which is with breakfast. So it's like we're staring down in the bowl with Gordon, and then we rotate the camera up and we look out at this landscape and we see the first clue. We see the thing. We see a data point. I mean, that's a piece of data that when they saw that at first, that's what led them to come back to analyze it. That's data, but for me, it's kind of a vehicle. I want to find the right vehicle to communicate that point. So we do it on the stage of the glacier. And then Act 2 takes place in the helicopter. And where I want to get in the story is I want to then get us to the fjord. So the story ends on a ship where they're looking to see where that warm water is coming from. And I thought that kind of spatially it made sense. We start on the glacier and then we fly out over onto the fjord and hover there kind of between the ice and the water. And then we end on the water. So there's this kind of physical movement through the story. And so it's all, and in so doing, I'm actually looking in that scene at a real data plot, but I'm hoping that the kind of being in the helicopter elevates the kind of moment a little bit, that something's happening. And when I was on the helicopter, I had some inkling that I might use that scene in that way. So I made sure to ask Gordon, so like, what does this mean? Why is 4.04 degrees Celsius important? And so I got him saying that on the helicopter. So let me take a moment and talk about my perception of what science is. So scientists approach a scene, approach a part of the world or part of the universe or something inside our bodies, and they make observations. And those observations are never an exact replica of the thing it is they're observing. They're observing it maybe once an hour, once a second, once every centimeter or something, but it's never, even if it's really high resolution, it's not forever. So there's always some way in which it's not exactly the same thing. Early on, it's sort of a coarser representation of that scene. Later, with better technology, it usually gets better and you get a finer resolution, but it's never exactly the thing. Now, what do? Well, I go, there's my microphone, that's me not stepping in a crevasse. On my fourth day, we got to walk on the glacier. So I interrogate these places and I ask people questions. And I take that same space and I usually kind of paint it in, a lot of it in broad strokes and focus on an idea or on some element in crisp detail. So something like this. So a lot of it is kind of just coarse, but then I try to bring one aspect into finer resolution. And I think about when I go into the field to actually collect this material, I think about it like gathering clay. Now you're about to hear from a real sculptor, but what I do, I think of as a kind of sculpting. I go out and I'm collecting sound and visuals, and I think about how to organize those bits of clay into something that'll hold up as a narrative object later. So I've talked a little bit about, I think, how scientists think about data. But there's another piece that I think is really important, and that's how scientists feel about data. And I'm going to quote myself here, because I wrote in this email exchange we've been having. I say, I look at data with scientists. They explain what it means and why it matters, and it's through their words that I come to understand not just the science, but who the scientists are as well, and what gives their lives meaning. And so, in fact, just today, I had a phone conversation with a scientist, and he wrote me later and he said, it was nice talking with you, although I'm not sure if I've ever talked to a stranger before about such personal things. Thanks. So we're still talking, which is good. So, I mean, I do that a lot. There's like the science, but then there's the person behind the science. So I'm going to end with one other example. This is a graphical rendition of our galaxy, the Milky Way. And I want to tell you about an astrophysicist who's based at the Harvard-Smithsonian Center for Astrophysics, Margaret Geller, who early in her career as a graduate student asked the question of how are galaxies distributed in our universe? Are they just kind of randomly strewn across the universe, or is there some structure to how to what's out there? And so Margaret and her colleagues looked into this. We had some sense, but we had no specific sense of what it was like. And they worked and worked and worked, and finally they had it. They had a plot of a very small part of what the universe looked like. For the first time, they could see it, and this is what that plot looked like. And so the red and blue, these are galaxies that are distributed throughout one little wedge of our universe. I mean, this doesn't go out, I mean, it goes out far for like walking standards, but in terms of, in terms of the universe, it's quite small. So you see already that there's structure to how the galaxies are distributed. They tend to cluster, and there are these larger pockets where there's not a lot going on. As the data improved, they were able to look at a wider wedge with greater resolution, and that's what this looks like. Each yellow dot is a galaxy. And you see this beautiful webbing of our universe, that there's this structure. Margaret talks about it as being able to view the largest patterns in nature. So when she's telling me that, I mean, it's full of awe in its own right. But I wanted to know what it was like for Margaret to be there and to see that. So she and her two colleagues, so there were three of them, saw this for the first time, and I asked her what it was like.
It's an amazing feeling. It's a feeling you never forget. And there's a certain awe in the patterns that nature makes. And and that we can discover those. And there's a kind of special thrill in being the one to see it for the first time. And you know you're the only three for that moment. You're the only three that know it. That's it. In the whole world, of the billions of people in the world, it's yours for that moment. And so for that moment, you own the universe.
I love that in that moment she owns the universe. She actually was holding a part of the universe. She has a thing on her desk, and it's actually this other image, similar to this other image. It's a glass cube, and so she can actually hold it. So for me, that's, when I think of subjective data, that's what I think about. I think about, like, there is this objective reality that's out there, but as humans, we can't help but bring our own subjective being and experience to it. And so often what I try to do is kind of uncover what that is for the scientist, what's underneath that. Because I think it's in those statements, when you hear someone talking about what it's like to hold and own a part of the universe for a moment before it goes public and before everyone can get their hands on it, it's those moments that I think we can all relate to. So with that, I'm going to turn it over to Nathalie.